An unprecedented demand driven by the surge of AI native application requires a fundamental shift in how we scale and distribute our wireless network. The session explores how distributed MIMO orchestrated by AI within an Open RAN framework provides breakthrough spectral efficiency while maintaining scalability. Joining us are Amanda Toman. She's director of the Wireless Innovation Fund, that at the NTIA at the Department of Commerce. Next to her is Doug Kirkpatrick. He's Chief Technology Officer, that at Eridan. Next is Soma Velayutham. He's General Manager AI and Telecoms at NVIDIA. And next to him is Velayutham Campbell. He's Chief Technology Officer of RAN and the RAN Business Unit at Rakuten Symphony. On the end is Tommaso Maladia. He's Director, Institute for Intelligent Network Systems and Professor at Northeastern University in the U.S. And all speakers, welcome. We have a number of you on this session for a reason. So interesting topic today, and we'll try to get through all the questions. Doug Kirkpatrick, CTO over at Eridan, I want to start with you. Certainly, we've experienced traditional Massive MIMO over the years, and now we have this distributed Massive MIMO that can overcome some of those challenges. What are some of those?
I mean, it really comes down to two words. The fundamental thing that dMIMO does that classic Massive MIMO has a challenge with is what we would call dynamic scalability. So Massive MIMO, once you've put a 64 by 64 in, that's what you got. If you do a dMIMO system, you can deaggregate, reaggregate, you can add elements to it, you can subtract elements from it. So what you have now is a dynamic system that allows you to adapt to what's happening on a day-to-day or hour-to-hour basis.
I mean, I more or less agree with Doug. So the traditional MIMO system is based on the single site serving model, right? So you have a UE, which is served by the base station. And as a result of that, you have the cell center, cell edge scenarios. And cell edge UEs are basically, they see interference from the neighbors, and that's where the SINR is poor. Now, distributed MIMO solves this problem by transmitting from multiple TRPs, right? So the UEs, which are at the cell edge, could constructively combine the signal and get much higher SINR. So distributed MIMO certainly takes care of the coverage and capacity challenge, but it moves to the complexity of the synchronization and the advanced RAN feature. So not only you need synchronization and ideal front haul, but you need very advanced features for distributed MIMO. And one thing is that the MU-MIMO scheduler or AI RAN-based scheduler, where you can figure out what's your coordinating set, right? Because you wouldn't like to combine signal from all the TRPs. So those are the problems it solves, but there is a trade-off in terms of the distributed MIMO.
Tommaso, AI-driven orchestration certainly provides some advantages in distributed MIMO. What are some of those?
Yeah, so I think that's absolutely the essence of the problem here, right? So the distributed MIMO, the theory has been known for a decade at this point, right? We know the signal processing, and that's been known, but we've seen very limited commercial applicability of all of this. Why is that? Because Massive MIMO, at its essence, becomes a massive combinatorial problem, right? We have a very large number of antennas distributed on a certain area. We have spectrum, we have users, and we have potentially power, right? So how do we cluster the antennas together in a virtual base station? How do we assign spectrum and power to each individual base station? How do we assign users to each individual base station? How do we scale it up and down, right? So that's a complex combinatorial problem, which we haven't been able to address at scale in a distributed way. And through AI, right, with a hierarchy of AI controllers, closer to the base station with real-time applications and at a higher hierarchical level to coordinate the different virtual base stations, we can come up with systems that can learn how to best serve the users at any individual time, given the resources that are available. That's the key.
Soma, some of the advantages with AI-driven orchestration for distributed MIMO?
Yeah, as the panelists have said, the complexity increases. It solves the problem, but the mathematical complexity increases. And that's where, AI comes in and the programmability. AI is fundamentally a programmable problem. You need to be programmable, and if you want to be programmable, it has to be software defined. AI is not one thing that you do and you get it done with. So it's a programmable, software-defined problem, and this is where we come up with Eridan and an NVIDIA-based platform where you can actually reiterate the problem multiple times and solve the problem. Right? So increase complexity with using AI, and then AI solves the problem, and then with being software-defined and programmable, you actually can reiterate on the problem.
Doug, I wanted to go back to you and maybe give us some insight on how distributed MIMO is really enabling this feedback cycle between AI workloads and network capacity growth.
So I think one of the breakthroughs that's very, very recent is we, just a few months ago, put a couple of radios in Tommaso's lab. Tommaso was able to synthesize those into a combined network. So we're already starting to see the problems that need to be solved. Mm-hmm. One of the interesting things is that with the new all-digital radio that we started pioneering 10 years ago, is that some of those problems have just collapsed. They're now solved. They're done. It's now turned into the software problem that they were discussing. There are scalability challenges that we have to understand, and I want to make sure that we understand that that's not an unsolvable challenge. It's a very solvable challenge. And where we're trying to go with that is to understand what's the best route. And what's the best route that preserves not just the scalability, but preserves the dynamic scalability, because it's that dynamism, because our environment of what we want at any given moment in time will be changing. And that's what we want to see going forward into this next generation of MIMO.
Amanda, are there breakthroughs in distributed MIMO that you can share that are really allowing this to be more commercially viable, just from your perspective?
Yeah, well, thanks, Abe. I appreciate the invitation to be on the panel. So I'm at the NTIA, so the director of the Innovation Fund. We had a significant amount of money to try to invest in the commercial development of open and interoperable networks. So I think everybody on the panel has received funding from the Innovation Fund in one form or another. So we initially focused on testing and how to evaluate things like interoperability. So when it comes to Massive MIMO or distributed Massive MIMO, how can different radios easily interoperate with the back-end systems, spending significant funding there. Tommaso and his team at Northeastern have participated heavily in that first round of funding. And then with the second round, we focused on the radio unit. So specifically, not directly, all of them Massive MIMO, but a chance to look at the hardware. So how could we enable really the open front haul and enable that interoperability so that things like Massive MIMO using that open front haul interface are something that can be easily deployed and do so more readily. So Eridan is one of our investments, and they're making great strides with the money they've been given. So looking forward to their Open RAN radio becoming commercially viable here. Really, that's the desired output of our funding. So, we'd like to see it quicker, but I think we've made great progress, and continuing to see the collaboration amongst all of the folks on the panel has been really promising.
Tommaso, anything to add as far as that collaboration?
Oh, the collaboration has been fantastic, and some of these synergies have emerged through the Innovation Fund, through the NTIA Innovation Fund. In fact, we were connected with Eridan and started working on this a few months ago, and there's been very steady progress since. I would say, the ecosystem is changing in general, and there is really an AI capacity loop, right? There is AI at the edge demands more capacity, right? We have distributed MIMO and distributed Massive MIMO can provide more capacity, but it requires AI itself to be able to deliver the capacity that we need, right? And this is where architectures, open, interoperable, accelerated on GPU architectures, where compute and wireless are integrated into a single fabric, becomes really game changer.
Yeah, it's a good segue. Soma, I wanted to ask you about that GPU accelerated platforms and the AI modeling, really improving in network coordination, interference management, and really spectral efficiency as well. Can you shed some light on that?
Yeah. The promise of Massive MIMO was to deliver much more spectral efficient. But then in the field, you realize Massive MIMO actually delivers like 25% of what it was actually promised. There's a theoretical limit, and if you look at what's actually delivered, it's actually 25%. And those who have deployed can say that. And the reason for that is actually the computational problem, because radio is not a parameterization problem, it's an organic thing. It's living, breathing, every moment is moving, and it has to be recomputed and recalculated. That's why AI is a very good solution for this problem. It's always calculating and improving. So using AI, we believe that we can massively improve the spectral efficiency, and having Eridan radio and the concept of dMIMO, actually we pair both of them. So we are looking forward to really showcasing, and we work with Tommaso and the team, where AI and how do we use AI for RAN and improving the spectral efficiency.
And I want to start with Amanda, but we can definitely get Doug's feedback as well. As far as these spectral frameworks, allocation strategies from the NTIA's perspective, how is that supporting, and I think you touched on this a little bit earlier, but how is that supporting the commercial viability of these distributed MIMO models?
Yeah, so I think with Open RAN, right, the promise of incorporating dynamic spectrum sharing and using AI to do that is definitely one of the things we would like to see happen, right? So as we know, there will be more spectrum coming available for 6G. That's in the future, but I know there will be much excitement about using that additional spectrum. So, but in the future, really, it should be a dynamic environment, right? So being able to use these advanced radio units, these advanced antennas, applying AI, being able to operate really in a truly dynamic environment, I think is something that we as a government should be interested in pursuing and ensuring successful.
Doug?
I mean, what's interesting is you've got every stakeholder that's been involved in doing this up here on the stage at once. I mean, literally all of us are working together. We work very closely with NVIDIA, we work very closely with Rakuten, we work very closely with Northeastern, and obviously with the NTIA. And as you look at that kind of problem, and you look at this next generation of technology, which is not just now dynamically scalable from Massive MIMO into dMIMO, the underlying digital radio is also instantaneously tunable. I mean, I haven't sprung that one on Tommaso yet because I didn't want to make his life completely miserable. But underneath all of this, the next thing you can layer on top is not only can the radios aggregate and re-aggregate, but in the future, once we can move the regulatory pieces, they can change frequencies at the same time. So the level of flexibility that you can bring and the level of complication that you can solve starts to become really fantastic in terms of being able to bring everything up at once.
Vihang, I wanted to ask you about maybe lessons learned already with dMIMO and some of these deployments, and also in the Open RAN space as well, from Rakuten Symphony's perspective.
Based on the early, trials and the Open RAN, trials, I think the challenges are not conceptual, as Tommaso said. The feature is there from 4G days, right? It's the COM feature essentially, but the challenges are at the system level and the operational level, right? And the main thing is the front haul latency and the fluctuations. Even slightest jitters could cause the dMIMO gains to evaporate. Right, that's one thing. The second is the synchronization. Now, in order to constructively add signal at the UE, you need phase synchronization, you need timing synchronization, and you need frequency synchronization. And 3GPP has defined certain methods in terms of calibrating the frequency and the phase, but sometimes those methods depend on the UE feedback. So now you have an additional angle where the UE implementation is also going to impact your distributed MIMO gains. So those are some of the learnings in my view, and I feel that 3GPP has done incremental work, no doubt about it, but there is still a gap between the current distributed MIMO schemes and the coherent joint transmission. And all of us have to kind of worry about how do we bridge that gap. I think those are the learnings in my view.
Tommaso, I want to ask you a question and kind of go down the line here to wrap up. If operators had to get or to receive one takeaway as far as preparing for AI orchestrated dMIMO really at scale, what would that be?
So I would say as of today, there are a lot of systems and operational challenges, right? We need to put in place an architecture where AI can be used at scale to collect data and to introduce hierarchical decision making in the radio access network. Okay, this is something that architecturally doesn't exist today, and we need to prepare to do that. So that would be my number one recommendation. And then number two is, as Doug was mentioning, we have to start putting things together, right? Distributed MIMO and spectrum sharing as of today are, for example, two problems that we are tackling in completely separate ways and with different operational rules, etc. We need to start thinking about these things together. When I create a distributed MIMO virtual array, I need to decide how to allocate spectrum at the same time, because the two problems are intertwined. And if I change the solution to one of the two problems, that affects the other one.
Vihang, anything to add?
Again, in my view, we need to kind of bridge the gap between the coherent joint transmission and where we are currently. And I think it needs support from the entire ecosystem, right? You need 3GPP to come up with mature standards. You need, UE chipset vendors to come up with modems which can, have advanced receiver. You need operators to spend money on laying the ideal front haul, right? And the AI RAN has to be part of the baseband, right? Because the schemes where you are able to optimize the cooperating set for the distributed MIMO has to be part of the RAN baseband software. Similarly, you should enable all the third-party applications which have sometimes specialized knowledge about how to make a distributed MIMO work. So all of these things have to come together. So I think it's a punt on distributed MIMO, but I think it's well worth taking that risk, because for 6G, I feel it will be part of the baseline, portfolio itself.
Soma?
Yeah, I concur. First is we need to have a baseband that's highly programmable and AI native. We don't want to push fixed functions into radios. We want to have highly programmable basebands. That's number one. Number two, that I think we didn't get a chance to talk about is a lot of this will have to be born in simulation. A highly accurate, physically accurate digital twin will be so important to get all these ideas from the gentleman and lady to get this thing going, because having a very highly accurate digital twin is where you can actually test all these ideas and then improve and then deploy. So for highly programmable, AI native, and a digital twin that's physically accurate.
Doug?
Add one more layer on top of that, which I'm sure Amanda will second, is we also need the regulatory environment that supports this. I think all of us are on board that the first major step is the AI native RAN. We already have an AI native digital radio. Obviously, that's why this is working so quickly. The second is the AI native RAN. The third is getting all of the structures that we were discussing about 3GPP and all of those processes on board. And obviously, the piece that will have to come after that is regulatory, because without the regulatory changes, the idea that we can do all of this dynamism is never going to happen, because that's not the way the world was when those regulations were put in place 20 years ago.
Amanda?
Yeah. So I agree with everything that's been said. The one thing I do want to really amplify is the AI RAN. So we've recognized that this is really where we need to be focused and investing. So we are going to be basically publishing our last NOFO opportunity focused on AI RAN. So I say that to mean really trying to invest in an AI native network, really trying to push the convergence of mobile and IT to make it something so it really is not just an evolution, but a revolution in the way networking is done, and really trying to push the ecosystem. So I look forward to that announcement coming out. It'll be an opportunity to hear from industry and get input about all of these topics, right? So how do you do dynamic spectrum sharing? How can we actually demonstrate the utility of the aspects that you're speaking about that can then push regulatory changes, right? So looking forward to that, and looking forward to how this industry participates in that last opportunity.
So scaling the network with distributed MIMO. Again, Doug mentioned that all the right sort of players are up here speaking at once. So that's it's a luxury, and we appreciate that. Tommaso with Northeastern, we appreciate you being here.
Pleasure.
V. Heng with Rakuten Symphony, thank you so much.
Thank you very much.
Soma, it's great to have you with NVIDIA. Thank you so much. Doug, thanks for being here. Thanks for supporting this session as well.
Thank you for having us.
Appreciate it. Amanda, as always, yeah, we'll have you on again in just about 5 minutes. Appreciate it. Until next time.